polymetric materials can outgas in the space environment, causing mass loss, not only affects the performance of the materials itself, the outgassing products and its formed self-atmosphere have also detrimental effects on the spacecraft itself. Therefore, it is important for materials outgassing research. Although research in this area has a lot of achievements, but the lack of systematic summary analysis, and there is still the key issue is not resolved, affect the effective control of the material outgassing. Spacecraft development is mainly concerned with the practice of the total mass loss, compounds of outgassing and control measures in 3 areas. In this paper, the results of these studies have been carried out systematically, summarized in 3 areas, pointed out the direction of future work. Outgassing phenomenon and its impact. Any materials in a vacuum environment will lose its mass. Material will evaporate, molecules absorbed on the surface will desorb. Also, organic polymer in the production of polymerization process will contain a large number of low molecular weight additives. The compounds contained within the material will diffuse to the material surface and desorb from the surface. Evaporation of the materials is related to its saturated vapor pressure. Polymers used in spacecraft have very low vapor pressure, so in the normal operating temperatures, mass loss caused by evaporation are small. Therefore, the main consideration is outgassing caused by mass loss. As can be seen in Figure 1, the outgassing results in brown-colored deposits on aluminum panel, which is clear evidence of exits of outgassing. And there are many lessons learned about outgassing impacts. Outgassing can easily have serious impact for spaceborne optical system, I-4 devices, scientific exploration tasks, etc. Figure 1. Contamination from internal outgassing of spacecraft. The brown-colored outgassing deposits on aluminum panel. 2.1. The impact of deep space exploration spacecraft. In the first moon orbital flight by Apollo 8, the silicon rubber seals outgassed severely and contaminated large observation window, so had to temporarily move to a less contaminated small view window to take picture and video. On Apollo 14, the sealed motor, which failed during flight, the reason is that the room temperature vulcanized RTV silicon rubber used during operation outgassed silicon compounds with low molecular weight and outgassed silicon-formed carbon particles with petroleum-based lubricant in the brush or action. Increased brush marks led to monitor failure. European Comet Probe Rosetta mission used a quadruple pass spectrometer for detection of comets surrounding gas composition. Analysis showed that material outgassing severely affect the results of the detection of the gas components. In deep space exploration, as the most important feature of the origin of life, water detection is one of the main tasks, and material outgassing of water is the main component for one of them, so its direct impact on mission success. Test configuration shown in Figure 5. Materials placed in temperature-controlled effusion cell. Quartz crystal microbalances are temperature-controlled tight. A QCM for low temperature, liquid nitrogen cooling to collect all of its surface impinges outgassing product. TML total mass loss of a function of time is determined by the quality and geometric relationships deposited thereon. The VCM determined by the QCM temperature. Inside the test chamber is shroud, i.e. molecular sink. 3 QCM were controlled at different temperatures, such as the in situ material outgassing TML and CVCM, such that in the in situ material TML and CVCM at different surface temperatures can be measured. Standard required temperature control accuracy of QCM should be better than plus or minus 0.5 Celsius. In E1559, there are 2 method options, Test Method A and Test Method B. Method A, the various test parameters, was of strict rules. 3. QCM operating temperatures are 90K, 160K, and 298K. Method B allows the user to select the sample heating temperature, the QCM temperature, and other parameters so as to perform the material outgassing test for a specific task possible. 2 test methods tested samples at 3 temperatures, 398K, 348K, and 324K. The duration is 1 to 5 days. The test method of E1559 is characterized in using 3 different temperatures, T, Q, Cm. It can provide dynamic data of outgassing in different time and temperature. The use of QCM, thermogravimetric analysis, QTGA, also gives composition, desorption temperature, the absorption heat or condensation, and other information about the outgassing component. 5. Identification of compounds of materials outgassing. Materials outgassing products contain complex compounds, and its concentration is extremely low. Commonly used analysis methods are mass spectrometry and infrared spectrometry. It was found that water is one of the most important products of outgassing, mainly from material processing and storage environment. Relatively loose structure of the polymer material, microscopic pores larger than the diameter of a variety of common gas molecules, therefore polymers can dissolve a variety of gases. Solubility depends on the affinity between the material and the gas molecules. Water is a polar molecule. The affinity is relatively large, so the solubility is high, and this is the reason why water is one of the main products of outgassing. Chen P.T. et al. Used low-temperature cold-finger to collect outgassing products in thermal vacuum tests by using mass spectrometry to identify compounds. Through statistical analysis, it is found that the molecular weight of more than 100 of outgassing products, mainly siloxane and phthalate esters. Yokozawa H. et al. Using infrared spectroscopy for outgassing products analysis. The method further improved can be used for real-time analysis of outgassing compounds. Identification of compounds of material outgassing products should combine with material outgassing tests described in Section 4, aimed at obtaining total amounts of different outgassing products. Possible methods include temperature-controlled QCM in combination with mass spectrometry, temperature-controlled QCM in combination with infrared spectroscopy.